Okay, so what I would like you to do to start off today is to do the try this. It's just like yesterday. The function is f of x is equal to x squared plus 2. I want you to evaluate all of these values over here right below it. Okay, so put me on pause, do that, and then come back and check your answers. All right, so for the first one, f of 1.9 is 5.61. F of 1.99 is 5.9601, and F of 1.999 is 5.996001. F of 2.01 is 6.0401. Those are zeros. F of 2.001 is 6.004001, and F of 2.0001 is 6.00040001. So hopefully you remember from yesterday that look at my x values. My x value is 1.9, 1.99, 1.999, so that's approaching 2. 2.01, 2.001, 2.0001. These also are approaching 2. So as my x approaches 2, my y values, 5.6, 5.9, 5.99, 6.0, 6.00, 6.000, that my y values are approaching 6. So my limit, so I have a limit, as my x approaches 2 of f of x, and my f of x, I actually have a function of x squared plus 2. My limit is 6. So as x approaches 2, my y approaches 6. So if I want to figure out a limit using my function, using the equation, does it mean that I have to do all these different values to figure out, all right, so if it's approaching 2, I'm going to get 6. If it's approaching 2 on the right, I'm going to get 6. What if I just plug in 2 as my x value, right? This is approaching 2, approaching 2, approaching 2, approaching 2, approaching 2. What if I just plug in 2? Well, let's see. If I do f of 2, do I get 6? I get 2 squared plus 2, so that's 4 plus 2, which is 6. Yeah, so if I just plug in 2, if x is approaching 2, I get 6 as my y value. So that is called direct substitution. All right, so let's write that down. A limit can be evaluated. A limit can be evaluated by direct substitution. So therefore, the limit as x approaches c, so in this case my c was 2, of my function, what do? I take this value, c, and I plug it in for my x value for my function and evaluate. Okay, obviously there's going to be times when this won't always work, and we'll get to this as we move along in limits. Okay? All right, so number 1, the examples. It says to find the limit using direct substitution. All right, so number 1 is find the limit as x approaches 4 of x squared. So right down here, we're going to put the work. So we have 4, we're plugging in 4 for the x. So we have 4 squared, which is 16. So the limit as x approaches 4 of x squared is equal to 16. Number 2, the limit as x approaches negative 6 of 5x. So down here, we'll put our work. So we have 5 times negative 6. So we're just plugging in the negative 6 for x, which is negative 30. So the limit as x approaches negative 6 of 5x is negative 30. Number 3, the limit as x approaches 9 of the square root of x. So again, we're going to plug in x. So we have the square root of 9, which is 3. So the limit as x approaches 9 of x squared is 3. Number 4, we have the limit as x approaches 3 of x plus 4, the whole thing squared. So we'll put our work down here. So we have parentheses 3 plus 4 squared. That is 7 squared, which is 49. So the limit as x approaches 3 of x plus 4, the whole thing squared, is 49. Number 5, the limit as x approaches negative 2 of x squared plus x minus 6. So again, we're going to plug in negative 2. So I have negative 2 squared plus negative 2 minus 6. So that's 4 minus 2 minus 6. So that's 2 minus 6, which is negative 4. So the limit as x approaches negative 2 of x squared plus x minus 6 is negative 4. Number 6, the limit as x approaches negative 1 of x squared plus x minus 6 over x plus 3. So again, we're going to plug in negative 1. So we have here negative 1 squared plus negative 1 minus 6 over negative 1 plus 3. So that's 1 minus 6 over 2. So that's negative 6 over 2, which is negative 3. So the limit as x approaches negative 1 of x squared plus x minus 6 over x plus 3 is negative 3. Okay, so super easy today. This kind of makes up for yesterday's long video. So I hope you guys have a good day. Stay well.